Hello everyone, this is Robert, and this is the Prusa XL with the new XL enclosure. And this is one of the strangest products in the 3D printing world right now, and probably one of the weirdest I've ever reviewed. This is going to be a strange video because there is a lot to talk about, so let's get started talking about the XL with the new XL enclosure. So let's get some obvious stuff out of the way first. As always, please feel free to use the chapters to skip around. I have everything nicely labeled so you can find exactly what you're looking for. Secondly, this enclosure was sent to me directly from Prusa. We've been kind of talking after my recent XL videos, reviews, and stuff like that. So they reached out to me and asked if I want an enclosure, and I said, of course. But beyond that, there's really no arrangement. I don't have an affiliate link down below. I guess I could sign up, but I don't have an affiliate link, so there's no incentives there. They didn't pay me for this review, and they will be seeing it the exact same time that everyone else is, and I'm not going to be reaching out to them with any comments or suggestions until after the fact. So there's that. This does come as a kit, and it's relatively expensive. I think right now it's like $650. If you get it in addition to the printer, it's only like $520, and for people like me that actually bought this printer, there's a bit of a discount. That's all on their site. I don't need to go into that many details. But what I want to cover in this video is just how complicated this is to put together. Since it is a kit, it's very involved. It takes quite a bit of time. So here in a minute, we're going to travel back in time and I'll show you what it took to actually get this thing together. And you can kind of judge for yourself the pain points and if it is worth doing, or if you just want to pick another hobby altogether and abandon 3D printing completely. So let's go into the assembly of the Prusa XL enclosure. So I'm not going to create a full detailed assembly guide because quite frankly, Prusa already has that. They have this in picture form on their website. I have a link down below to that if you kind of want to get a better idea of every single step. If you've ever dealt with Prusa stuff before, their assembly guides are extremely detailed, very good, lots of really great pictures. So they're going to do a better job than I'm going to do. I'm just going to kind of run you over the details. But of course, everything shows up in a single box. Everything is very, very well packaged and labeled. I don't really see any issues with shipping damage with this, and it does follow the guide actually much better than I felt the assembly guide for the original XL was. It seems like they've had a little bit more time to iron out some details, and this assembly guide from start to finish was pretty good. I didn't really have any large hiccups from it, so that was nice. The whole assembly is kind of broken out into 4 discrete steps. You kind of have the top of the enclosure, which is what I'm doing here. You have the modifications of the actual printer so that you can attach everything. Then you have the modification of the tool heads, then attaching it, and kind of that final calibration stuff. The first 2 steps are kind of the most difficult, and everything after that is a little bit easier. Assembling the top was fairly straightforward, but the thing that you should know about this whole kit is you assemble everything. Nothing is pre-assembled. Everything is just bare components. You put in every screw, you put in every nut, and every single last little thing is something that you assemble. There are no sub-assemblies here whatsoever. So although it's easy, it is relatively time-consuming, and their instructions are very, very good, but oftentimes a little bit too detailed. So if you're just putting in like 5 screws, it might be 5 steps. It's like grab this piece, grab that piece, grab the 5 screws. Are you sure that you have the screws? Are they the right screws? Are you sure it's this piece? Orient it this way. There was a lot of steps where it was very clear that you should be using the left piece. Make sure you have the left piece, but the left and the right are exact mirror images. And then as soon as you get done with the left piece, it's like, okay, do the exact same thing on the right. So it really didn't matter that you had the left or the right. So sometimes the instructions are just overly detailed and it ends up making you go a little bit slower. But that being said, you end up, not having any issues, which I guess is nice. Okay, so I've got the top of the enclosure built, and this took 1 hour and 15 minutes. I've been kind of timing everything to give you a good idea, and that's not with filming or anything like that. That's just 1 hour and 15 minutes is about what this is going to take to make. It kind of adds up. It's longer than you'd think. Overall, it's pretty cool. I do like this little door lift thing. The magnets are a good touch. They're in the right spot. It looks kind of weird because they're just kind of these nubs sitting on top, but overall the functionality is nice getting in there. We'll see how it is when it's actually on the printer. It's a little like flimsy right now, but of course this is going to get mounted onto the structure of the XL, so that shouldn't be an issue. The one weird thing that I don't like is the fan on the back. Let me flip this around and I'll show you what I mean. So this is the exhaust fan. You might have been able to see it from the front, but there's a filter that slides down inside of there. This is the little tab for it right up there. To change out that filter, you need to undo these 4 screws, pull off this whole housing, and then pull out the filter. And that is very odd to me because you know where this is going to be sitting? Up against the wall. This already adds some depth. Not exactly sure if it's going to add depth to the overall printer because there's some other stuff on the printer that's sticking out, but this kind of sticks out. So getting a screwdriver in from this angle, pulling this out, you might be pretty well up against the wall. So swapping out this filter is going to be a real pain. They could have had a slit or something along this top that allowed you to slide it out, but it does not have that. So maybe there will be some kind of modification that people will end up making for that, but I was pretty unhappy to see how that's done. Before I attach this, there's one more thing I wanted to mention, which was the LED lighting. It's right here. Just right here, not on both sides. Even though these parts are exactly mirrored, they have the same features, they have the same like zip tie and attachment points. I've got screws going into 1, 2, 3 right here. Open holes, 1, 2, 3. There absolutely could have been an LED strip on that side, an LED strip on that side. I think for the fact that this is $650, they could have sprung for the extra few dollars for an LED strip on the other side. Of course, they are kind of custom Prusa LED strips that are on their own PCB, blah, 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 because, I don't know, maybe LED strips are not available there, but it's kind of weird that you only have one little LED strip on this side, but all the mounting and all the attachment is over there. I'm sure it comes down to, you know, the wiring and the plugs, but you could figure that out. You could make it go to this, daisy chain to the other side, and then go into the controller. So I thought that was kind of disappointing. This thing is just going to shine light from one side, which it would be nice if it came from both sides. So this is where things get a little bit strange. In the first step, you build kind of that top enclosure, and now I'm modifying the printer to kind of accept all the other pieces. So you have the Bellows system up front, you have a lot of wiring and stuff that goes in the back, and then you have attachment points for everything. And spoiler, there's a lot of PETG components, or a couple PETG components on the inside that cannot withstand the temperatures of an enclosure that need to be replaced. So I was under the impression that the XL kind of was designed with an enclosure in mind. But when you do the assembly of this enclosure, that thought just goes right out the window. So this next section was not my favorite. This took about another hour and 15 minutes. Loosely, you could probably get it done in about an hour, but there is a lot of kind of moving around in big pieces. You know, need a lot of workbench space, but about another hour and 15 minutes. So we're about 2.5 hours in. All the stuff in the back, I really, really disliked. Undoing all the zip ties, unplugging everything, replugging it back in. It's very tight back there. The wire maintenance, as I've said this a zillion times with Prusa, is give 50% more room than you do for wires. They give you just the bare minimum, and it's really annoying. But anyway, it went together. I think everything was fine. This is weird. I'm not saying it's bad. I think I kind of like it because you can just kind of do that. The thing that I didn't really realize is it's just kind of magnetically held in place, which is interesting, but it's not keyed into anywhere. So that kind of works. Oh, the magnet came out. Awesome. Okay, the magnet's back in there. So it can kind of work like that. Or you can kind of, you know, push it back where it's actually in place. Super bizarre. Like the fact that this isn't keyed into anything, it's just kind of magnetically held in place. And by the way, as you saw, the magnets aren't held in place by anything. So you can kind of maybe knock them out of their channel in theory. I'm going to put some like very thin, shallow foam bumpers on here because it's kind of extreme when it hits up here and it fits tighter than you might want it to. Super strange. And moving it up and down, you just kind of rub against this back surface. You might notice that mine are not orange. I reprinted something to make it black because I really hate the orange. I don't know. I am just kind of speechless with this because, yeah, that's not going to wear. I do like that it comes out. That gives you some clearance if you're printing something big or have some issues or need to service it. That's kind of cool, but it's just weird. I don't know. I'm speechless. I got nothing else to say about it. It's just strange. So many ideas about this are just odd. So anyway, moving on to the next step, 2.5 hours in. Now we gotta like rebuild all the tool heads. Awesome. So I got all 5 of these tool heads rebuilt, and really all you're doing is replacing this little idler arm as well as the latch and then the fan duct down below. You're replacing those 3 with components that can withstand the higher heat. This whole process took about an hour. Most of the time was on this first one right here, and the rest of the time was spent on the others, and I got it down to maybe like 10 minutes on the last ones. I wanted to point out why this one took so long. So this is the tensioning mechanism up here. You have this little guy that flips out, goes in there, this comes down, latches. Cool. So when this latches, you're actually pulling against these springs. Notice how the springs are kind of dipping down, and the pivot point right here is not in line with the actual screws. So when you're pushing this down, you're not pulling perfectly horizontally against these screws and against these springs. You're kind of pulling down a little bit. This is just a little tiny 3D printed part that has self-tapping holes in it. So when you screw these machine screws into this little piece right there, if it doesn't go in perfectly perpendicular, you're basically going to be pulling against the threads of these screws. Even though these are shoulder bolts, which have a flat and then a thread, the threads actually travel through this metal piece. So when you pull against it and try and snap that in place, you're pulling against the threads which are resting and riding on this metal section. So what I end up doing is pulling this apart and adding a little bit of a chamfer on the holes at the end of this so that it's a little bit smoother of a transition. If you get any kind of burr or rough spot through this metal section, the threads of the screw are going to kind of catch on it and this won't be very smooth. Ideally, if this is done properly, when you push on this, you can kind of see those springs compress. That's how it should be, but if there's any resistance in that path, you're going to have an issue. So that was kind of interesting. So for the subsequent ones, what I did is, this just kind of comes off. When I screwed this in, I kind of exaggerated it and kind of pressed it up like that so that you're actually pushing kind of down in, and that kind of exaggerates those threads a little bit because they're too small of threads and this piece is way too small to really screw it in perfectly perpendicular every single time. It doesn't really find it perfectly. So anyway, that was kind of a weird little thing, but once I noticed that, I did a little bit differently on the other ones, and they all work okay. This still isn't my favorite tensioning mechanism. It's not as smooth as you might think, and I spent some time trying to adjust it and get it just right, but it functions. It's just not as smooth as maybe it originally was, but oh well. At this point, all that's left to do is take that top section, plop it on top, add a couple screws, connect a couple connectors, and you're good to go. This was all pretty straightforward. Okay, so everything is now fully together. That took about 15 minutes or so to put that on, so not too bad. So we're at, what, 3:45? So just under 4 hours. Now we gotta turn the thing on and do all the belt tensioning. So apparently you go into the menu in the firmware, update the firmware, and then you select that you have the enclosure. It does something, and then you go through the belt tensioning process. So yeah, I'll just kind of let you know how long that takes because it looks like they have a really good tutorial online. So I'm gonna go do that and I'll be right back. Bye. So the belt tensioning was actually a lot more straightforward than I thought it would be. And I actually went back earlier in the video and made some edits just to kind of clear that up because I was kind of freaking out before. In the instruction manual, they have a link. You go to the link on your phone, you would allow your microphone access to that website. You don't need to download anything, install anything, or log in, nothing like that. It's just a URL that you go to. Select which printer you have, and then when you move the gantry to a certain point that they specify, you pluck the belt and it will tell you if it's too tight or too loose. Pretty clever, seems to work pretty well. I did a test print after calibrating the belt, and everything looks to be working just fine. So that was actually a lot easier than I thought. Now it's time to talk about all the weird, strange stuff about this enclosure. So I'm just kind of gonna zoom in and we're gonna look at all of the strange stuff that I've noticed thus far. And then when we get through all of those little rants, we'll print some ASA on it and see how it goes. So let's do some ranting. For anyone that is watching this video straight through, I'm gonna kind of reiterate some points because I want people that are skipping around to kind of see all these different chapters and they might have missed this earlier. So first thing that is just super weird that I just can't get over, I'm gonna lose sleep over this, are the bellows. I like the functionality. I actually think it's really clever. When you open this up, you have a ton of access into the printer, and that's kind of been my gripe with other printers that I've thrown into an enclosure, is it just makes it a nightmare to service and use and kind of get inside. With the bellows down, you can very easily get out the build plates, get it back in. You have really good accessibility. That's not what I'm kind of griping about. What I'm griping about is just how this was designed. The theme to all of this is it just feels like such a strange afterthought. There's no features on this whatsoever. It is just this metal accordion thing that's really well made. Totally fine with that. The handles are fine, I guess. The handles do prevent you from putting any filament spools here and there, which is kind of interesting. I'm gonna have to figure out how you fit 5 spools if you can't use the front. Doesn't matter. The thing that's weird is that you have this little skirt down below and it attaches in and it has magnets. And if I put it like that, I showed this earlier, that works. Kind of hard to see from the video, but this is, I don't know, 3 inches out from the front. There's really nothing to keep it where it's supposed to be. The magnets are just kind of in the middle and then it doesn't key into anything. And this can kind of scrape against this back piece. It's just, I don't know, it's just this little magnetic C that just kind of goes on there. What I find the most fascinating is Prusa is super into 3D printing stuff. They love printing PETG with their print farm. It's their favorite little thing in the world. And you have these accessory pieces up front, which kind of don't really do anything. They're mostly cosmetic. If these were designed to just come up a little bit in the corners, then this would find its way into that and it would be in place and nice and snug. You also have an extrusion along this whole side. You could do the same with a little flap that just kind of runs here. You also have an extrusion here. There's a lot of places to put keying locations that would keep it where you want it to be. It doesn't have any of that, which is really strange. This just baffles my mind. And you have all these little vents and all these little features, and this thing just kind of slaps in place. In addition to that, look at the instructions for how the magnets are held in place. It's the most bizarre thing I've ever seen. You basically have a piece from the bottom, the magnet kind of slips on top and it screws in. You can just look at the instructions, but these magnets really aren't held in place by anything. And the ones up top have come out a few times. They came out earlier on video. If there's enough force pulling them, they can just kind of pull out. There are absolutely magnets that have countersunk holes in the top of them that you can actually thread in, like, there you go, focus on it. Yeah, they make these. They absolutely make these. You could just do that. Like this, actually, I think this magnet will actually fit. This magnet would actually just fit on the underside and just screw it. It's just weird what they chose to do for this. I'm not saying it doesn't work, and I'm not saying I don't like it. It's just odd. There are some really odd design choices with this Bellows. It does work though, and it is pretty slick, and I think I'll end up liking it. It's just strange. All right, let's talk a little bit more about the lighting strips. I know I already talked about this previously, but once again, for people that are skipping around, it has one light strip over here, and admittedly, it does do a pretty good job. When the whole thing is all together, it does have nice illumination inside. Two of them would be better, but one of them definitely does get the job done. If this was really dim inside, I'd have a problem. The thing that just baffles my mind, though, is this piece is an exact mirror of this one and has all the mounting holes, all the zip tie locations, but they're not used for anything. And there's actually a lot of mounting holes still in this thing. I don't know if you can see that, but there's 1, 2, 3, 4, 5, 6 up this side, 6 up this side. Nothing goes in them. There's a lot of additional mounting holes in this thing. And this just leaves me speechless because there was no additional mounting holes for mounting the enclosure. You think on the printer they would have had like these accessory holes. It's like, when we do an enclosure, we can use these holes for that. The printer itself has none of that. The enclosure has a ton of that. I don't know what's going to go on this enclosure. Is there going to be another printer that's going to go on this enclosure? And they have mounting holes for a second set of lights and they're not using them. That's just, it's so weird. That being said, let's turn off the lights and I'll show you what they look like with all the lights off. It's pretty good. Obviously, this is kind of accentuating it because it's dark in here, but overall, it is pretty decent, the lighting that's inside of there. Another strip would have been even better. There's mounting for it, and I'm pretty sure the power supply could handle this. And the wire routing, the best part about this, the wire routing is actually back in that corner. So it's, I don't know, 3 inches away from where that LED strip would have gone. So you could have had a cable that wide off, one goes over here, one goes over there. It's not like it would have been any extra cabling. It's just really, really strange, the choice that was made with the LED lighting. So this is the lid. Kind of lifts up, gains you access, comes back down. You can move the bellows down, right? There is a very sizable gap along this whole edge. Like, you know, I can almost get I can pretty much get a pinky inside of there. That's fine. Maybe this is where the air is coming in. There's an exhaust fan. Oh, you can't really see it, but it's all the way in the back up there. Maybe that's kind of an exhaust thing. Maybe the air is rushing in through here. That would kind of make it come across the top of the build plate. I don't think that would be great, but whatever. But what's really, really weird to me is they could have put a feature at the top of this that would have prevented this from kind of bowing in. It could have given it a stop, and it could have also been something to rest against. You could have had a gasket, but okay. It's just weird how much of a gap there is here. This junction just seems odd when, in reality, this is always going to stop at these rails. It can't come up any further than that. So this is always going to be at the same plane. This comes down. I just don't understand it. It's like a perfectly good gap across the whole thing. I don't understand that. Maybe I'll put some gasket on there. I am not sure. You can stop watching this video at any time. I'm just going to keep going because I could do this till 3 in the morning. These stops are clever, but also really, really strange. What they are is this right here is a magnet, a very strong magnet that's like rubber coated with a thread. Haven't really seen anything like that, but it's kind of interesting. And that kind of screws in there, and then this comes up, and then it like locks in place. It's pretty clever, and it does work out pretty well, but it's strange. And the reason it's strange is the way this is done is this is like a rubber foot. So this is just a rubber foot that they're using on a screw that comes through as a spacer. Oh God, this is never gonna come off now. Ugh. And then this goes on top. Like I said, it works, but what I find very strange about this is a gas strut or a gas spring on this mechanism would have been amazing, because once it gets past this point, it's just free fall. You could have easily done what so many other companies do with a vertical lifting lid, which is just to put a gas spring on it. You know, those things that you go, and then it pulls down. Right now, it just free falls. And the height of this when it's fully up, let's measure that. This is very tall when it's all the way up. It's taller than me. I'm on a stool right now. This is like the worst video I've ever made. We're about 82, 83 inches, something like that. It's taller than me to get to this handle at the very top when it's all the way up. So the likelihood of this falling down is pretty high. And yeah, this was a clever solution, but it looks really strange just having these like nubs on the top, and it doesn't do anything to support this. It could have been a gas strut or a gas spring. That would have been really slick. So I think this is the most confusing thing of all that I noticed, and maybe there's something here that I'm missing, maybe not. So follow me. In the back up there, you can kind of see it way back in there is the fan. So this does have a fan. Whenever you're 3D printing in an enclosure, everything inside kind of heats up because the heat bed is on, you're blowing off of the nozzle, so everything is going to accumulate heat. So you usually need a fan to kind of, keep the temperature at bay. Especially if you're printing something like ABS or ASA that has like 100-degree bed temperature, it just kind of starts getting pretty warm inside there. And that's generally what you want, but it can maybe get too warm. So let's just kind of go from there. It has an exhaust fan that is also used for exhausting, fumes and gases and stuff like that. Let's ignore the fact that there's a lot of gaps. Honestly, I'm being real here. Maybe that is for the intake. Maybe they have designed all of this as the air intake so that you have a little bit of, pressure in the inside. That's fine. What I'm kind of curious about is this is the temperature sensor that it comes with, and it doesn't talk to anything. The fan you can talk to. I can go down here to, I think, enclosure settings. I can go to filtration, and I can, I think, turn the fan on from here, something like that. So that's fine and dandy. I'm sure maybe in G-code you could also control the fan as well. But there's no temperature feedback at all. There's no way to actually read the temperature from the machine inside of this. When I did the disassembly in step 2 and you take everything off of the main controller board, there is a header for temperature. You don't get a temperature probe. There is no temperature probe. There is nothing inside this chamber that tells you what the inside chamber is other than this little thing that snaps in place. But it doesn't talk to anything. The display that it has there, that's all you get. So I am suspecting, just from reading the manuals and everything else, that this is just filtration. This is just filtering out fumes, but there is no way to bring the temperature inside the chamber down. Like, let's say it's getting up too hot if you're printing a long PLA print. You can't use the fan to exhaust out. Not used for that. The enclosure doesn't function like that. I'm guessing right now that Prusa is saying, For PLA prints, you just do that. Cool, fair enough. But from my understanding, this fan really isn't tied into anything. And there's a temperature input on the back of the board that isn't used. All the wiring and all the cutting and zip tying I had to do, I didn't once wire in a temperature probe. The other weird thing is if you go into Control and go down to here into Enclosure, there is literally a menu option that is temperature. And it doesn't read anything. So this Enclosure has the hardware for it, has the menu system for it, but they don't give you a temperature probe. So you cannot read the internal temperature. I have no idea what the temperature is inside of this, except for going up to it and looking at this little thing, which is of course up here on the door, not really centrally located anywhere else. And that is just the weirdest thing to me, that this thing costs about the same price as a Bamboo P1S, just for the enclosure, costs about as much as a very capable 3D printer right now, and you don't get a temperature sensor to read the temperature back into the printer. Wild. So I think this is the last and final thing that I'm going to gripe about before we put in some ASA and confirm that it will print just as fine as with the shower curtain. This is the back of the unit just to kind of give you a better look. These are all the filament tubes, then you have the actual wires for the tool heads. This is all kind of standard. This is just how the XL normally is. Here is the little connector block. The connector block, I don't know. I don't want to talk about it anymore, but it's just kind of weird that you have wires that come out of this that go into a connecting block and then the connecting block back into this. And in some cases you had to remove wires that were already in here and move them over to that, like this colorful one that kind of looks out of place. I just don't know why this wasn't already made with like a little expansion port on the back, that you had a nice single structured cable that you just plugged in and that was the control for everything. You literally have to take this off, this whole thing off, take all that off, unplug every single extruder, I'm not kidding here, unplug every single extruder, unplug the antenna, take the antenna off, take off, something else, and then wire all this in, clip all the zip ties, rewire it, re-zip tie it, just to get a fan connected in and the LED lighting connected in. But they all go through this little board, and this little board could just connect into the little expansion port that doesn't exist. So that's kind of weird. Obviously you can see a huge bundle of wire here. The fan cable is like that much longer than it needs to be. And there was actually a comment on the installation instructions like, why is this 3 feet longer than it needs to be? And there was nothing. So you just kind of zip tie it up in this little bundle in the back. It's interesting. I talked about the fan a little bit earlier in the assembly. To swap out the HEPA filter that's in here, you have to fully remove this full thing, pull out the filter, and then fully install this back, which is, once again, strange. I don't know why you couldn't just lift it up from the top. In theory, I could just Dremel a slot in the top of this and it would allow it to kind of pop out. I don't know. Maybe there's a good reason for that. The other last final thing about the back is that this, it's kind of hard to see and I can't really flip this around better, but this is about flush with the back. Like if you pressed all these wires, you could theoretically get it pressed up against here aside from the Wi-Fi antenna. So let's say from here about an inch out is kind of the back of the machine. This is another 2 inches out from that. It sticks out 3 inches from this plane. So 2 additional inches is what that fan gives you. I guess there's not a better place for it. Maybe it could have gone here. I don't know. I'm done trying to assume things, but it does add another 2 inches to the depth. So when you factor in this and factor in the fact that the screen is kind of leaping off the front of the device, you're looking from the screen all the way back to here, 30.5 inches. I have 36-inch deep workbenches and it can just barely fit on here. A 24-inch shelf, 24-inch deep shelf is pretty standard, and this will not, no questions, will not fit on a 24-inch deep shelf. It will almost barely fit on a 30-inch deep shelf, but you'd probably knock against the LCD screen that's kind of coming off the front. So it is a deep, deep boy. 30.5 inches is what you need, and that is jammed up against this and to the very, very front of the LCD. So it's actually quite large. It doesn't add anything to the width. The width stays exactly the same. And to its credit, the height is maybe only about half an inch or an inch taller. The tubes and the wiring for the heads are like right here. They're right at the very top. So it really doesn't add that much height. I'm curious when I put it back in my corner how much height this door is going to add, because it lifts up quite far, but that's kind of in the front, so it's something else. So yeah, I don't know. It's a lot deeper. The wire management is strange, and it's just strange all around. So many strange things. For the test print, I'm printing one of the front panels for my modular filament storage system. I'm printing one of these because I know the model and I know that it kind of does tend to warp a little bit if there are drafts, and I'm printing this out of Prusa's Galaxy Black ASA. This ASA is amazing. And you'll see this when I show the finished part later, but it looks flawless. It's just beautiful, beautiful filament, and it prints really well on this printer. I didn't suspect I would have any issues with this, but I did use a fully clean build plate. Sometimes, a lot of times with ASA, I'll use a little bit of glue stick, but in this case, I just did a fully cleaned, textured build plate, and everything stuck and everything worked just fine. If you look at the temperature sensor up top, you can see when it's in focus that it fluctuates around 37, 37 and a half once everything kind of gets up to temp, and that's about 99 degrees Fahrenheit, a little bit over that. So it's definitely maintaining about around that 100 degree Fahrenheit mark. So everything works as it should. It controls for drafts, it allows you to print ASA. Anecdotally, I didn't really smell any ASA fumes. I don't actually think the filtration was on, but this is a sealed enclosure, or relatively sealed enclosure, so I really didn't get any fumes, although ASA is a lot less than what you would get from ABS. So yeah, everything, non-surprisingly, worked out the way I thought it would. So let's take a look at the finished part. And here is the finished part. As I said, I used the textured build plate just so that we could see that bottom layer. If there was any lifting, it'd be very apparent, but it is a perfectly smooth texture on the bottom. And honestly, this is about as good as it gets for 3D printing. Perfectly smooth. There's really no layers. I think you'd have to get under a microscope to really see the individual strands there. So it looks really nice. The edges, super, super clean. This Galaxy Black ASA is amazing. This is ASA, folks. So yeah, looks absolutely fantastic, no issues. All of these parts do warp a little bit in the middle when they're released from the bed, just to the higher thermal mass on the side. So when it kind of cools down, it lifts a little bit. This actually happened on every printer I tried and was more pronounced on the Bamboo X1C because it just kind of turns on that big fan and cools everything really quickly, so it warps more. But yeah, everything looks fantastic. So yeah, the XL with an enclosure can absolutely print ASA beautifully. Do I have to do a conclusion? This is going to be kind of difficult. When I first started this video, I was talking to my wife about doing some kind of editing where I kind of like had the angel and the demon, and I did like a red filter and a blue filter to kind of indicate, you know, my mixed feelings on this. On one side, it absolutely does the thing. It works perfectly for what it's supposed to do. As an enclosure that seals in the juices and stops drafts from happening and getting the internal chamber up to enough temperature to print ASA and ABS, it does that. It does that wonderfully. I really don't see any issues with it. I actually really like the Bellows. I know maybe this is kind of confusing because I'm saying how strange it is. I actually really like this as a solution because for PLA or any filament that you really don't want the internal chamber to get too hot, You can just pop this down, but maybe still have the lid on for dust and other things. I like it. I like it as a solution. I also like that this comes off. I was really worried. Some of you might notice, try not to hit my T over there. Some of you might notice that I kind of store my extra build plates down here. This is just like a little aftermarket thing you can get on printables. I was really hoping that it didn't interfere with that, and taking this off, it works out quite well. So I really like the Bellows. I like this as a solution. I like that right now this thing is so open, it doesn't feel like it's an enclosed printer. The tool heads are going to be a little bit more tricky to get to. It was kind of nice where you could just swing the thing around and access the tool heads from the back, but you know, that's just the nature of having an enclosure. So all of that aside, the enclosure itself I really, really enjoy. I think this is what I was looking for, and if I was going to design something, it would end up ergonomically and functionally being basically this. That being said, from a professional company with many years, decades in the 3D printing industry and the manufacturing industry, I am surprised that the level of manufacturing and design is maybe not where I would expect it to be. I think that's maybe the softest way of saying that, is the fact that I'm just pushing a bar magnet into a slot that's cut out of a steel piece. You know, little things like that are just kind of weird, that I'm putting, like, I don't know if you can see up there, but putting like little rubber caps on the end of a exposed nut that's just kind of coming out the side. Very, very thin plexiglass or Lexan. I'm not really sure if that's acrylic or what that is, but just, you know, relatively thin panels. Like, this is kind of stuff that most individual makers can do now. You can go to Send Cut Send and get this stuff made, and these little push rivets, I can get these on AliExpress or eBay, or the little temperature sensor thing up here. That's something that you can get for like a nickel. You know, these are all things that are in the realm of capability for just a standard average maker at this point. I will admit that some of the sheet metal stuff is beyond the level of most makers, but don't challenge me. If you use a company like Send Cut Send, they actually do sheet metal bending and stuff. You could actually do a small production run of these. What I guess I was expecting, and still am expecting from Prusa, is more injection molded, more, you know, tempered glass, more things that are out of the scope of what I can do as a maker. And when you get this as a kit and spend 4 hours assembling it, and it costs $650, there's just a disconnect. I have a problem with that. My brain doesn't fully compute that. If it was just a thing that snapped on top and you're done in 10 minutes, it's easier to swallow that $650. But for 650 bucks, you can go out and get a P1S that you open the box, pull it out, plug it in, and within 10 minutes, you're printing kind of reference quality 3D print, you know, give or take. So all of those things very much still exist to me. And in doing this review, I don't want to try and bash on Prusa too much. I thought about this a lot. So in my day job, in my real life outside of YouTube, I am a manager. Technically my title is CEO, but you know, I'm a manager. And I do a lot of performance appraisals for my employees, for my managers, and for my management team. And whenever I go into a PA, the thing that I like to explain to them is I am being tasked right now with giving you a few things. One, I'm giving you a realistic expectation of what I see as your job and how you are performing the job. In addition, I'm also giving you kind of a reflection of how you're viewed and your work is viewed from the company. How many times have you been at a company and you're working really hard and you just don't really know if you're doing well or you're not doing well? So in a performance assessment, you want to give a realistic reflection of how they're viewed by not only their peers, by their employees, by the company as a whole. You know, thumbs up, thumbs down, room for improvement, whatever. And the last thing is you want to give an employee a really good sense of what things might be holding them back from achieving that next level. So if you work on X, Y, and Z, that's really going to get you to that C-level executive job. And that's kind of how I'm approaching this review with Prusa, is I want to give this feedback because other companies, other employees, are providing this level of build quality. I mean, we saw the Sunlu that was, or not the Sunlu, the S1 from FL Sun that was in here, a month ago. And the build quality of that thing is fantastic. I mean, it couldn't print. It's terrible. But the build quality of that thing was amazing. It's an 85-pound piece of machinery for $1,500. That's a couple times what this enclosure is. And I mean, you're getting glass, you're getting these huge extruded panels, like extrude aluminum. Wow, that's not something I can do. That'd be really neat if we could start seeing these large custom extrusions. They're at the volume. They're at the volume, they can leverage economies of scale. I'm just not sure why they're doing it. I'm not sure why they're relying so much on that print farm that's producing average level parts when they could be leveraging other manufacturing technologies. So when I approach a review like this, all I want to do is those three key things. I want to kind of give it a reflection of how I think they're viewed in the market as compared to all the other things that I see through my shop. I want to kind of, assess this for what it does. And quite frankly, I think it does what it's supposed to do. I'm actually excited for using this enclosure because it doesn't take anything away from the experience that I had with the XL, and it only adds to it. So that's good. But I think Prusa does need to hear some of the feedback that I'm putting out, that it is very expensive when compared to a lot of the other stuff on the market. The build quality, although you end up getting something that works, the build quality isn't what you would expect for something that's $650, and you have to spend 4 hours of your own time. And it doesn't really seem like it was really well thought out in the ecosystem of the XL, seeing as you have to do so many modifications to the machine to get it working. So that's kind of where I'm at. Overall, if you get it and you install it and you need an enclosure, you're gonna be happy. Your wallet might not be happy. This whole thing as it stands is about $4,000 right now. And if you want to go in and add hardened nozzles and everything, you're probably looking at another $200, $250, something like that. I think $250. So you're going to be about $4,250, and you're going to have to spend about a half a day building the XL and about a half a day building the enclosure. So you got to figure out if that's worth it. I already have a separate video on kind of the XL versus the Bamboo X1C. They're kind of very different. But if you need the XL and you want what the XL provides you, it still does the thing. It prints beautifully. It's relatively fast now. The tool changer, at least for me, is working really well. And with the enclosure, now I can print pretty much every material out there. So at the end of the day, what you're getting is something good, but it's expensive. So hopefully this gives you a little bit better idea of the enclosure and what it takes to install. I will say a little bit, the 4-hour time, I'd factor in another hour. What you can't see, boxes, packaging, boxes, this whole workbench is full of stuff. It's going to take me at least another hour to clean up all of the stuff. Add in the fact that you got to kind of take this off of where, move this printer to where it was, do the install and kind of move it back. You're going to add at least another hour on top of that. So if you're kind of like, looking to bang this out pretty quick, I'd say 4 is the absolute minimum. You're probably looking at between 5 and 6 hours total to put this together and be back to a shop that's not just absolutely destroyed like mine is right now. So anyway, thanks for watching this insanely long video. And if you have any questions, please post them down below, and I'll see you in the next video. Bye.